this is Eric IT. Welcome to this video in which I'll show you how to configure router on a stick. First, let's talk a little bit about router on a stick. What is it? Well, router on a stick is a type of router configuration in which a single physical interface manages traffic between multiple VLANs on a network. The router's interface is divided into sub-interfaces which act as a default gateway to their respective VLANs. So why was router on a stick born? Well, in times before, routers had to have one physical interface per each VLAN that you had on your network, making it a lot of expensive to have this because routers have fewer interfaces than a switch does. So if you had 10 VLANs, you should have 10 router interfaces for each VLAN, one for each VLAN. So it was very expensive because routers commonly have 2 up to 3 interfaces. So router on a stick was born to fix that, and we're gonna see an example of how to configure it and how to have it working and do an example with these two PCs that I have here. I'm gonna be using 2 VLANs just for this practical example. I'm gonna be using VLAN 10 and VLAN 20. PC1 is going to belong to VLAN 10 and PC2 is going to belong to VLAN 20. I'm gonna use the fast Ethernet 0/0 interface from the router 1, and I have this switch here, which is in GNS3. I already have it configured for the 0 port that is connected to the router 1 to act as a trunk link using .1q encapsulation. And the first port, which is port 1, is going to be in access mode in VLAN 10 for the PC1 and access port in VLAN 20 for the PC2. So now that we have this configured, we can go right to the router 1 to complete the configuration on router on a stick. Let's begin. Okay, here is I console into the router. Let's configure terminal. The first thing to know about router on a stick is that you never configure anything on the physical interface. You just have to turn it on and leave it like that. No configuration on the physical interface, just turning it on. Let's do it. Interface fast Ethernet 0/0, no shutdown, and that will be it. Then we are going to proceed with creating these sub-interfaces I told you about, which the command is interface fast Ethernet 0/0, which is the physical interface that all those logical interfaces, which are called sub-interfaces, are going to be binded to. All those logical interfaces are going to belong to a single physical interface. So each sub-interface belongs to a VLAN. You can select a number from up to 4 billions, so you have a plenty of options. It's typically used that you match the number of the sub-interface with the VLAN that is going to be configured on it. In this case, I'm gonna use number 10, but not necessarily it has to be the same of the VLAN that you're going to configure on the sub-interface, but for best practices, that's what it is used. And then for being able to assign an IP address to this sub-interface, we have to set the encapsulation type and the tag, which is the VLAN number that we are going to be using this sub-interface for. The command is encapsulation, then the type, which is .1q, and next we're gonna define the tag, which is for VLAN 10 in this case, and then we can proceed with assigning an IP address of this subnet that we are going to be using for the VLAN 10, which I'm going to be using the IP address or the subnet 192.168.10.254 for this device with a 24-bit mask. That will be it for this server interface. Let's go with the next one, which is interface facility_0/0.20 encapsulation .1q and 20. We're going to assign the IP address to this interface 20.254 with a 24-bit mask. That will be it. Let's see how it looks in the show IP interface brief table. As you can see, physical interface has nothing on it, it's just turned on. And now appear two sub-interfaces, which is one corresponding for VLAN 10 and VLAN 20. Now that we have this already configured, we can begin with doing some tests, but not before. We have to assign IP addresses to these devices, so it will work connectivity between these two different subnets. I'm gonna console into these PCs. I'm gonna assign an IP address which is like this: IP 192.168.10.1 with a 24-bit mask, and next the gateway that this subnet has, which is 10.254, and there it is. We're going to go next with the PC2. Here it is, IP 192.168.121.1, 24-bit mask, and the gateway, which is 254. That would be it. Let's go back to the PC1. Let's do a ping in this device to reach the PC2, which has the IP 20.1. Let's see if it works. It does work. The first ping is lost due to ARP, but as soon as it gets the MAC address of the other device, or I mean of the gateway, now it can have full connectivity. Let's do it from PC2 to PC1, which has the 10.1, and as you can see, it can successfully ping the other device. So right now, both PCs, even they are in different VLANs, they can ping each other because there's a configuration on the router that does an inter-VLAN routing between those two, having this interface configured as a trunk port. And well, just to see that the router knows about each of these IPs from the 10.1 and 20.1 that are from PC1 and PC2. Let's do a show ARP, and we can see their IP address and their MAC address in the ARP table. So this video was to show you how to configure router on a stick. I hope you enjoy it. See you next time.